Hey everyone, in this video we'll talk about that how we can perform enqueue operation in queue. Let's start. So we have already discussed about these things that queue follows the FIFO mechanism. So in the last video I have discussed about the box office example that in box office we follow the FIFO. So now we'll talk about the operations of the queue, and in this video I'll talk about the enqueue operation. So we have two types of operations, one is enqueue and another one is dequeue. So in this video I'll talk about enqueue. So as you can see in my screen, that algorithm of enqueue is written over there. Now at first what do we have to do? We have to check that our queue is full or not. If our queue is full, then we cannot insert any element within our queue. If our queue is not full, then we can only insert the elements within our queue. Then we have to check that if our queue is full, then we'll just say that our queue is overflow, else we'll increment the rear and add element. So what is rear counter, what is front counter, we'll talk about that now. So as you can see in my screen, we have declared a global entity that is queue. We have taken two pointers, one is rear and another one is front. Initially the value of the rear is -1 and the value of the front is -1. Now as you can see that this queue is empty. So in stack initially the top is -1, in queue initially the rear and front is -1. So you can see that rear and front are -1. Now if we are trying to insert anything within our queue, at first we have to check that our queue is empty or not. So now our queue is empty. So how we can identify that? We have to check that rear equals to -1 or front equals to -1 or not. If both are in -1, it means our queue is empty. So if our queue is empty, at first we'll increment our rear and front counter. So we'll perform the enqueue. So now our rear is -1 and front is also -1. So we'll increment both of the pointers together. So we'll insert 20 over here and we'll increment front and rear together. So now the value of the front is 0 and the value of the rear is 0. Now we'll enqueue another element, that is 40. Now you just pause this video and write in the chat section that what will be the value of the rear and what will be the value of the front. You just pause this video and write in the comment section. I hope you have written the command. So the front will be still 0 and the rear will be 1. So our front will remain here. We'll just increment the value of the rear. So we'll only increment the value of the front and rear together when our queue is empty. So if you enqueue 50, then what will be the value of the front? It will still be 0 and the rear will be 2. If we enqueue 60, then the front will be 0, the rear will be 3. If you enqueue 70, the front will be 0 and the rear will be 4. So why we are not moving our front counter? So whenever we are trying to perform the dequeue operation or delete anything, then we'll move our front pointer. So till now we haven't deleted anything, that's why our front is still 0. So in my dequeue video I'll talk about that how we can move our front pointer. So I think this portion is clear, that how we can insert any element within a queue. So this is one of the most important thing that you have to remember, that is we will increment our front and rear together when both of the pointers are in -1. So I think these portions are clear. Now we'll see that how we can implement enqueue. So at first what we have to do, we have to check that our queue is empty or not. So how we can say that our queue is empty? So if our rear equals to -1 and front is also equals to -1, then we can say that our queue is empty. And how we can say that our queue is full? We have to check that our rear equals to size -1 or not. Let's say that we have 10 elements, or let's say 0, 1, 2, 3, 4, 5. So what is the size of the queue? That is 6. If we, let's say that we have rear here, rear equals to size -1, it means rear equals to 5. It means we cannot insert anything within our queue. so it will just return that our queue is full, it will return true. And if our queue is empty, it will also return true. So these are the things that you have to follow. Now we'll see that how we can perform the enqueue operations and what are the steps we'll follow. So at first we'll check that our queue is full or not. If our queue is full, let's say that we have 4 elements within our queue, 0, 1, 2, 3, size of the 10, 20, 30, 40. Size of the queue is, let's say n. Size of the queue is 4. So our rare is also in 3. So how we can check that if our queue is full or not? We'll just check that 3 equals to 4 minus 1 or not. If it's true, then we'll simply say our queue is full, you cannot insert anything. Then what we'll check? We'll check that our queue is empty or not. So how we can say that our queue is empty? Let's say that we don't have any value within our queue. We don't have anything. Now our rear and front equals to minus 1. So if both of that are in minus 1, then we'll increment the front and rear. We'll just increment the front and rear, then we'll add the value. So let's say that we'll add 10, we'll increment the front and rear, both will be 0, we'll add 10. Now what is the value of rear and front? That is 0. Now if we are trying to insert another element, that is 20, then what we'll do? We'll just check this condition, queue is not full. We'll again check that is empty condition, queue is not empty. Then we'll just increment our rear and we'll just add the value. So what will be the value of the rear? It will be 1. See, here we are only incrementing rear, we are not incrementing front, and we'll insert 20 over here. So this is how we can implement enqueue operation in queue. If you have any doubt, just write in the comment section. Now we'll dive into code. So as you can see in my screen that I have written hashing to std.h, stdbull.h, and what is the size of the queue? That is 5. So initially the rear and front is minus 1. This is the function for checking that our queue is empty or not. This is the function for checking that our queue is full or not. So this is how we can print the queue. So this print queue is not related to our queue. I have just added this print queue only for your reference. So if our queue is not empty, we'll just print the values. Then this is the enqueue function. So at first we are checking that our queue is full or not. If our queue is full, then we'll simply print queue is full. Then we'll check that our queue is empty or not. If our queue is empty, then we'll move our front and rear pointer to 0 and we'll add the value. Else we'll just increment our rear counter and we will add the values in the queue, and you can write ++ here as well. So how many times we are calling the enqueue function? We are calling the enqueue functions 5 times. So what is the size of the queue? That is 5. So it means we cannot call this function because we have exceeded the limit. So we can only insert up to 5, then we are printing the queue. If we are trying to call this function, then it will simply return that our queue is full. So let me compile the code. So you can see that at first we have inserted 1, then we have inserted 2, then 3, 4 and 5, and at last when we are trying to insert 6, then we are simply saying that our queue is full. So this is how we can implement enqueue operation in queue. If you have any doubt, just write in the comment section. See you in the next video.